Welcome to another tutorial of ProfLearn YouTube channel. In this particular video, we're going to have a discussion on how to solve logarithmic equations and the rules that you must know. There's 8 rules that you must know in order to answer any question to do with logarithmic equation. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials like this ones, you'll be notified. Now, these are the rules that we are going to use in order to solve different questions involving logarithmic equations. Now, going to look at the first question here. Looking at the first question on our disposal, we are told that find the value of a such that log 8 over a log 8 base a equals to 3 over 4. And then we are going to follow step by step on how to approach that. And because the concept that they are trying to use here is the rule that if you're having log b base a is equals to x is the same as a raised to power x is equals to b, meaning that the base raised to the number that is on this side is going to be equal to this b that we have here. So this is the rule we are using. So we are going to say, using rule number 8, we are going to say a raised to power 3 over 4 is equals to what? Is equals to 8, right? And from the laws of indices, if we are having this one, we can be able to write it as the fourth root of a because of this 4 here. Then if this is raised to power 3 is equals to 8, which means that we are going to find cube root both sides, so that this and this will cancel out. We end up having the fourth root of a is equal to cube root of 8 is basically 2. Now, in order to get rid of the fourth root, we are going to raise to power 4. We raise to power 4, and of course this and this will cancel out, and we shall have our a is equivalent to 16 as our final answer in this point. So you must know that log of b base a equals to x can be expressed in index notation as a raised to power x is equals to this number here. So meaning the base raised to the number that you have here is equal to the b that we have at this point. So understanding conversion of logarithmic notation to index notation and index notation to logarithmic notation is very important as far as further pure math is concerned. The next question is that we need to show that 3x log x base 2 minus 4 log 8 base 16 plus 6x log 8 base 4 minus x log x base 2 is equals to log 8x raised to power 3x minus 1 base 2. So we are going to verify that whatever we have on the left hand side is equal to the right hand side. How are we going to go about this particular question? Now follow me with me here. We're going to say now solution to this problem. We are going to say that you see, if you are having this, we're going to say this is 3 log of x to the base of 2, and we're going to be minus. Now I want to express, and let me tell you, in order to solve this, we are going to express everything to the base of 2. I'm going to focus expressing everything to the base of 2, because if I look at this question that I'm having here, we are showing that this is equals to this. So meaning that our final answer should have base 2. So meaning whatever we have on the left hand side, we are going to express it to the base of 2. And if you have different bases, you can be able to express the base you want. And to do that, you are going to use which rule? You are going to use rule number 5. You are going to use rule number 5. Now, using rule number 5, you need to understand that if you're having log a base b, but you do want it in a different base, for instance, if you want it to base c, you are going to say it's log a base c over the base now over log b base c. Yeah. So for instance, if you are having log 16 base 2, let me say log 8 base 3, and I want to write this to the base of 2, I'm going to say log of 8 to the base of 2, the one I want, over log of this number that we have here, 3 to the base of 2. That's what we're going to do. I believe you've understood what I've said. Eh? If you are having log base 27 to the base of 5, and you want to express this to the base of a different, you want to express this to a different base that is not 5. So let's, for instance, say you want your expression to have base 2, you are going to say log 27 over log 5. Now you write the base of 2 that you want. If you have log a base b and you want it to have a base of c, you are going to say log a over log b, then you write the base c that you want. That is basically what we are going to do in question b. In order to express it in this format, we have to do that. So the second term is 4 log 8 base 16. So we have to change this base 16 to base 2. And to do that, we are going to say this is going to be equivalent to what? This is going to be equivalent to 4 log 8 over log 16. Then we write base 2. Then plus 6x, but this is base 4 and I want base 2. So I'm going to say log 8 log 4. Then I introduce base 2 that I want. Minus log of, this is going to be x base 2. Already it is in the format that it was. So let us try to see what is log 16 base 2 equivalent to, because there's this rule that says that log m base m is 1. So meaning if you have a number and that number is the base, then it means the answer is 1. So meaning, for instance, if you are having this guy here, log 16 base 2 can be written as I want you to remember that log 2 base 16 I want you to remember that log 16 base 2 can be written as log 2 power 4 base 2, and this power can go behind and we can have 4 log 2 base 2, and 2 base 2 is 1 because log m base m is equals to 1. So this is going to translate to 4. And this one that we're having here, log 4 base 2, can be written as log 2 squared base 2. And this 2 can go behind. So this 2 power 2 can go behind here. 2 log 2 base 2. And log 2 base 2 is equals to 1 because log m base m is 1. Then this is going to translate to 2. So meaning this part that we have here will be 2. And this part that we have here is going to be 4. So meaning that our expression now can be written as 3 log x base 2 minus 4 log 8 base 2 over 4, because we have said log 16 base 2 is 4, minus 6x log 8 base 2 over 2, because log 4 base 2 is 2, minus log x base 2. Now you can see this and this will cancel out. Here we are going to have 3x at this point, and our expression is going to translate to 3 log Now, in order to solve this question, what we're going to do, because this question has base 2 at the end, and we are trying to show that this part we have on the left-hand side is equals to what is on the right-hand side. So meaning that we are going to express every log that is here to the base of 2. So for us to express that, you need to remember that if you're having log a base b, if you want to introduce a different new alien, if you want to introduce a new alien base that was not there, you are going to say log A over log B, then you introduce that base that you want to introduce. So for instance, if you are having log 27 base 9, and you want to express this to the base of 2, you are going to say this is going to be equal to log 27 over log 9, then you introduce the base of 2 that you want to introduce. Basically, that is how you use this equation rule number 5. Now, in order to work out this, we're going to say we are going to express 2 base 2. That is the basis. Now, the first term here is going to be 3x log x base 2 is in the right base minus 4. This is log 8 base 16. So we're going to express that to base 2. So we're going to say log 8 over log 16, 8 over 16. Then we introduce the new base that we are interested with. For this one, we are going to say plus 6x log. The base is different, so we're going to say log 8 over log 4. Then we introduce the base that we want. But this one is in the correct base, so we're going to write it the way it is, log x to the base of 2. Now, something that I need to remind you is that we can be able to log 16 base 2 can be written as log 2 power 4, because 16 can be written 2 power 4, and we write our base there. From rule number 3, if you're having log a raised to power m, you can take m behind the log. So meaning that we can be able to say this is 4 log 2 base 2. Which will mean also we can be able to apply rule number 4, log m base m is 1. If you have a log of a number and the base is the same number, you are going to have 1 there. So meaning that this is going to be 4 at the end of the day. This meaning that this number we have here, we can replace that with 4. And let's see, we are having log 4 base 2. This can be written as log 2 base power 2 base 2, and this is 2 log 2 base 2, and that is going to be 2. And this part here can be replaced with 2. So our new expression now will become 3 log x base 2 minus 4 log 8 base 2 over 4 plus 6x log 8 base 2 over 2 minus log x base 2. So finally, we shall have this reducing to 3x log x base 2 minus this, and this will be log 8 base 2 plus this will go here 3x log 8 base 2 minus log x base 2 log x base 2. We need to go further, and in that way we can be able to say, let me put the like terms together, because we can say 3x log x base 2 minus log x base 2, this and that, and then plus log plus 3 log 8 base 2 minus log 8 base 2. I've subtracted this has 8 and this 8 so that I've put them together. This has x and this one has x, so I've put them together that way. Then we can be able to factor out log, and we shall have 3x minus 1 log x base 2 plus 3. All right, considering this and the last part of the expression, we are going to have 3x log x base 2 minus log x base 2. This one, it will be plus 3x log 8 base 2 minus log 8 base 2. This one here. So which means that we are going to factor out, we are going to group this together here, and we are going to have 3x minus 1 log x base 2 plus 3x minus 1 log 8 base 2. So if we have this, we can see that using rule number 3 in the reverse, if you are having m log a, you can take m up to be the power of a. All right, and then that is exactly what we are going to do here. We are going to take the powers up like that, and let me just try this. This can be written as log x power 3x minus 1 base 2 plus log 8 power 3x minus 1 base 2. And remember, when logs are added, we can be able to multiply them and express as a single log, which means log a plus log b, we can be able to say that's log a times b. At the same time, if you are having the same power, m power a times m power a times n power a is the same as m times n power a. Believe we are together up to that point. So I would like to make use of this space here because we are almost done with this question, and this part I believe you got value on how to work out this question. Let's now try to go further and simplify whatever we have. And whatever I'm having at this point here, I can be able to express it as a single log, and that is going to be equal to the log of x times 8, that is x power 3x plus 1 multiplied to 8 3x Now using rule number 1, if they are added, you can multiply the numbers. So meaning I can multiply this and this, then express as a single log. So this is going to be log of x raised to power 3x minus 1 multiplied to 8 raised to power 3x minus 1 to the base of 2. So if I have this, I can say now this is going together that way. And using this rule here, that if m power a times n power a, they are having the same powers, we can be able to say this can be expressed as log eight x times 8, that will be 8x raised to power 3x minus 1, right? And that is basically what we have here. That is basically what we have at that point. So that is exactly what we were supposed to show. Now, what you need to remember is that we have shown that this part that we have here from the previous question, that that is equivalent to log, the whole of this is equivalent to the log of 8x raised to power 3x minus 1 to the base 2. The whole of this is equals to this. Then now we can say, since we are told to solve this, they wanted us to simplify and know that this, so the whole of this can simplify to this. So they want us to solve this equation. So which means that we are going to say whatever we have said this is equivalent to can be equated to 0. So this is the equation that we need to solve in order to find the value of x. Now, the two ways we're going to approach this, we're going to say this is going to be log of 2. Now, in order to solve this, you can be able to remember the rule we use. In order to solve this, we are going to express in logarithmic notation. But before going into that, remember this rule that we are having here. If you're having log a power m, the power m can be written behind the log. So in that way, we can say this is going to be what? We can say this can be solved in the form of 3x minus 1 log 8x base 2 is equals to 0. We can be able to use that approach there. And in order to proceed, we can say if we divide by 3x minus 1, divide by 3x minus 1, what's going to happen? Let's see the worst that can happen. This will cancel out, and finally we shall have log 8x base 2 is equals to 0. Now, in index notation, this can be expressed how? Log b base a equals to x can be written as a power x, the base raised to the number that you have at this position. So meaning the base here is 2. We can be able to write this as, we can be able to say this in index notation, this can be written as 8x 2 raised to power 0 is 8x. We can be able to write it that way. This number raised to 0 equals to 8x. So meaning that 8x is equals to 1 because any number raised to 0 is basically 1. And we can say divide by 8, divide by 8, x is going to be equal to 1 over 8. That is one of the way we can be able to approach this question at this point. Another way we could approach this question is dealing with this expressing index notation while keeping this intact the way it is. And let me show you what I'm trying to say. We can be able to express this in index notation without taking the power down. So we are going to have 8x raised to power 3x minus 1 is equals to 2 raised to power 0. 2 raised to power 0. If you write that, it's going to be 8x 3x minus 1 is equals to 1. Now, how can you be able to get a 1 when you have a base 8x? The only you can do that is when you have 8 base x raised to power 3x minus 1 is equals to 8x raised to 0. That's when you can have a 1 here. So in order to work out what x is, we can say since the bases are equal, we can equate the powers, and that would be 3x minus 1 is equals to 0. And this goes on the other side, we shall have 3x is equals to 1 here, then divide by 3, then divide by 3, and get point. And if you can open your eyes widely, you will see that 3 and 3 will commit suicide and have x is equals to 1 over 3 as the second answer. So you can have x equals to 1 over 8 or x equals to 1 over 3 for you to be able to have this as the solution of this equation that we were having at this particular point. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial like this one, you'll be notified. Let's move to the next question. Now, looking at these two questions, we can see profoundly, we can see that vividly what is coming out is having different bases. Looking at this question and this question, we're having different bases. So meaning that you have really to master rule number 5. Now, in order to work out this, we are going to express everything to the base of 2 so that we can be able to find this equation. And to that, I'm going to say this is going to be log x power 3 base 2 plus. How am I going to express this to base 2? I'm going to say this is going to be log x squared over log 4, log x squared over 4. Then I introduce the base I want. And then this will be minus 3 log of this to the base of this is to the base of x. So I can say this is going to be 2 over log x. Then I introduce the base 2 that I want. Then I'll say now this is equals to what? Is equals to 0. Is equals to 0. All right, so this guy is a standalone there. Meaning, if we are going to simplify this, and I've mentioned and opined from the previous section that if you're having log 4 base 2 is the same as log 2 squared base 2, so this power can go behind and have log 2 base 2, and the answer is 2 here. So this part that we have here can be replaced with 2, and meaning that our expression is going to reduce to log x cubed base 2 plus log x squared base 2 over 2 minus, and this one log 2 base 2, when you have log m base m, the answer is 1. When the base, the number, and the log base is the same, you say is 1. So this is going to reduce to minus 3 over log x base 2, and everything is equals to 0. We are almost home and dry. So we can say this can be written as log we can take the log behind, we can take the powers down behind the log, so we are going to say 3 log x base 2 plus 2 log x base 2 over 2, and this will cancel out, minus 3 over log x base 2 is equals to 0. If I want to make things cleaner here, I can see that I'll have 3 log x base 2 plus log x base 2 is equal to 3 minus 3 over log x base 2 is equal to